Over here on the right, we have some log properties that we're going to need to remember. And we're going to practice with them so much that it's going to become natural. We won't even be thinking about them. The first is that the log base A of 1 is 0. Remember that A must be positive and can't be 1. And this particular relationship here makes sense because this has the equivalent exponent statement, A to the 0 is 1. And it makes sense that anything I raise to the 0 power is 1. So the log base A of 1 will always be 0. The log base A of A is 1. Again, this makes sense because if we convert it to its exponent relationship, it says A to the 1 is A. And anything we raise to the first power, we get back. This one, log base A of A to the x is x, can be seen by converting it to its exponent form. Its exponent form would be the base A raised to the exponent x. A to the x is equal to the argument here, A to the x. And anything is equal to itself, so we can see that this relationship is always going to be true. This statement we could find to be true by converting this exponent relationship to its corresponding log relationship. Its log relationship would be the log base A of x is equal to the exponent, the log base A of x. And again, we have something that's equal to itself. Now these here are the corresponding properties just using E as the base. Again, E is so important, and this natural log is so important that in just about any textbook you find, you're going to find the natural log properties written out, even though they are nothing more than just a specific base for these general log properties. Again, if we were to convert this to its exponent form, it would say e to the 0 is 1, because the base is e, is understood because we have the natural log. E to the 1 is e. E to the x is e to the x. And the natural log of x is equal to the natural log of x. So all these properties are the same properties that we have up here. It's just that the base is understood to be e. So let's look at this problem. It says evaluate the expression without a calculator. Okay, well, our first property said that the log base A of 1 is 0 regardless of what the base is. Here the base is 5, but it's still 0. This says to find the exact value of the logarithm. Log base 6 of 216. Well, whenever we think of 216, we might think of 6 cubed. And this property, log base A of A to the x is x, says that if this base and this base match, then the whole thing is just equal to the exponent. And we have that here. The log base 6 of 6 is equal to 3. So let's suppose we're asked to do the same thing. Evaluate this without a calculator. We have a 3 in the denominator here, and then 27, and 27 always makes us think of 3 cubed. So we could write this as the log base 1/3 of 3 cubed. But again, we're not quite the same. We've got 1/3 here and 3, but we really could make that 3 into a 1/3 if we wrote it like this. The log base 1/3 of 1/3 raised to the minus 3, because that is what negative exponents do. They move things across the fraction bar. So now we have an example of the property log base A of A is x, or log base A of A raised to the x is x. So here we have this base and this base matching. So this whole thing is just equal to minus 3. Log base 4 of the square root of 4. Well, let's see. We could rewrite this as log base 4 of 4 to the 1/2 power. The square root is just a 1/2 exponent. Again, the base and the base are the same, so the whole thing is just equal to the exponent.